Hi there. So, we've got our next, thanks for waving there, Gavin, proving he's still awake. Hi everyone, thanks for coming to see Marian's talk. So it's going to be on breaking Windows apps. So that's about to start. So after Marian, everyone's back in here. So this is the last of the double track. So after Marian, everyone's back in here from a talk from Cigital on Connects, as far as I can tell.
Okay, can everyone hear me? Yeah, it's obviously working. I've been going to make the crack right at the beginning of this presentation that the only people I would like you to get in here when there's a talk on crypto, the next room is likely to be thickos and web testers. I can see obviously I've not done very well in making a very entrancing presentation because most people have decided to go for crypto. You can't win against a talk against crypto, you're obviously not doing very well. So this is me, I work for Scott STS, which is a really small consultancy you won't have heard of. I've been in IT for 20 years, and if Rory Hood is in the room, I'd like to point out that I'm 40 plus and I'm still a technical security tester. I've been working with Microsoft products since DOS 3. That was about the time that Windows 3 came out, slightly later. I'm director of my own security company. I've been that for 3 years. Before that, I must have to admit, I was in IT management. My personal interests are web applications, Microsoft stuff, and mobile, Windows Phone. And there's a picture of my IT kit at home, which is 3 Surfaces and an Xbox. So I'm going to talk about Windows 8 store apps. I'm going to, first of all, talk about a little bit of background. I'm going to talk about the Windows Store itself. I'm going to show briefly some apps. Talk about the security architecture of this type of app. Talk about the Windows runtime, which is something that's very widely misunderstood. And then I'll talk about development environments, the store requirements and certification, and finally I'll go through what Microsoft actually do as far as testing this kind of app is concerned. So just a little bit of background first of all. That, in case anybody doesn't know what it is the sign for the Seattle Metro, and that is supposedly what Microsoft decided that they were going to base things on when they designed the Metro design language. So this is why the talk is called Metro Down the Tubes, because to start off with, when Windows 8 was being developed, Metro was the name not only for the design language, but also for this type of app. And then right around the time that Windows 8 actually went live, all of a sudden Microsoft dropped the whole name, and they never actually publicly really admitted what the real reason was. That the only thing that they said in public was the fact that it had only been something that was being used during the development phases of Windows 8. They never really intended it to be the real name. But the word on the street was that it actually was trademarked by AG Metro, who are a German company, and therefore they had to drop it because they were actually in partnership with them. So supposedly it was inspired by this Metro sign in Seattle, and the reason it was down the tubes was because it was gone, and had some people walked out of the tube station. The Windows Store, that's where these apps belong, and I take it everybody's seen Windows 8. So back in 2012 when this came out, I guess Apple and Google have both had stores for quite a while. So with Windows 8, it was obviously time for Microsoft to cut themselves a bit of the pie too. And I think possibly I'm being slightly unfair to them when I say that, because I think there really genuinely was another reason for it. Because I don't know whether anybody's actually been out there with a Windows PC recently and, for example, searched for, I don't know, free video editing software or free game or free anything, pictures of Emma Watson. It's a minefield out there. I mean, I've been, as I say, working with PCs for the last 20 plus years. It scares me actually going out there and actually downloading Windows binaries. You literally don't know what you're going to get. And if you're not careful, what you'll get will be a nasty dose of malware. And whilst I'm sure that there was an element in Microsoft's mind of, look, we can make 30% on all this revenue, there also was a great big enormous chunk of, we want to provide a safe environment for people to be able to trust Windows again and be able to actually go and look for software without thinking, oh God, my bank details are going to be on somebody's website before you can say Jack Robinson. So what kind of apps will you find in the store? We'll find all kinds of things. That's OneNote, the touch version of it. It's free, it's quite good. Then there's some sort of kind of like sample apps that Microsoft has provided. That's Bing Travel. And then there's a whole lot of games and things. That's quite a cool underwater one. So all different kinds of things. What you won't see in the Windows Store anytime, and Microsoft have actually said that this is going to be the case, you're not going to see programs on the lines of Visual Studio because they're just too complex and they're never going to be touch friendly, and probably they're never going to be able to be programmed in the kind of way that this kind of app has to be programmed. I'll come on to that in a moment. The other app that you are not going to see in the store in a hurry, and this is actually quite bad for testers, is you're not going to see the next Nmap written as a Windows Store app. And actually, if you go out, which I have, and go and search the Windows Store for things like Nmap, if you search, for example, for a network testing utility, you'll actually find that there are a few utilities out there. And I looked at them and I thought, well, you know, looking at the API, how on earth did they do that? And, well, they don't really. And I'll come to a little bit later on why you can't write that kind of utility for this type of environment. And the people that have developed that kind of utility are actually trying to work around the limitations of the environment, which is why when you do get an IP-based utility for the Windows Store, it's probably not going to be very good. First of all, the security architecture. This takes quite a lot from mobile, certainly much more than traditional Windows binary applications do, because all the apps run in a sandbox. And in Microsoft terms, the sandbox is called the app container. A really good analogy I read, and I wouldn't actually want to say this with my analogy, because it's in the book about Windows 8 store apps, is that the difference between a traditional Windows desktop app and a store app is the difference between a guest in a house and a guest in a hotel. So if you invite people into your house, they can go all over your house, probably while you're asleep. They can go to your garage, they can uninstall the nuts underneath the bonnet of your car. They can go and defecate on your carpet, they can go to your kitchen and splatter grease up the walls. And when they're gone, you're not really going to know exactly what they've done in your house. I mean, you know, have they been up in the attic? You know, what have they done? As against that, a Windows Store app is more like a guest in a hotel. So the guest in a hotel can come into his room and he can trash it, he can write sort of rude slogans on the walls, leave his towels on the floor of the bathroom. But once he's gone, the hotel knows exactly how to clear up after him. And they can clear everything away out of that room, and then the guest will be gone as though he'd never actually been. So by default, an application, a Windows Store application, has only got very, very, very limited privileges to run. And here we talk about something that's actually quite alien, I think, to most people who've administered the PC and indeed have developed for the PC. It very much makes the use of integrity levels. And basically what integrity levels are, they are kind of like an extension of an access control list. So with integrity levels in the new versions of Windows, it doesn't matter whether you are logged in as the administrator. It doesn't matter, you know, in what way you try to elevate your process. If you start off with a low integrity process, you're not able to interfere with other processes which have got a higher integrity level. And by default, in fact, anyway, all these type of apps run in an app container and they run as a low integrity process. So there you can see that this is sort of the security architecture, and there you can see your app processes running in their app container, and they are able to communicate with the system's APIs only in the limited areas to which they're restricted and by brokered access to other areas. So you can see there at the top there's the two areas that they actually have access to. So all this must make it sound as though these applications are actually very limited, because you know, here we have, you know, Windows 8, and the sort of devices that is being put on now are much more analogous to mobile devices than traditional Windows PCs. So you're getting a whole load of things that they've got proximity sensors, they've got GPS, they've got microphones, they've got video cameras. So are we saying that, you know, that these apps aren't able to utilize this kind of feature? Well, obviously not, otherwise they would be really totally useless. And so the way that they get around it is one of the most important things. So bear in mind, by default, they can only exist in their own app container, and they can only access that very limited amount of local storage that's actually designated to them. The way that you actually extend this is by a thing called capabilities. And capabilities are things like, for example, the ability to use the webcam, the ability to use the microphone, etc. And these will only be allowed to the app if the developer has actually declared them in the manifest when they submit the application to the Windows Store to be certified by Microsoft. So in other words, if you don't say that your app uses the microphone, then when it actually comes to run, if it attempts to access the microphone, it'll say, nope, nope, go away. If you have declared the use of the microphone in the manifest, then what the app will do is the very first time that it needs to access the microphone, it will actually ask the user. So you'll actually have seen the bar appear on the screen. It says to you, you know, do you want this finance app to allow your webcam to take photographs of you? And you might want to say no at that point. And so the idea is that the capabilities of the app are actually listed in the store next to it when you actually go in there. And I think the idea is supposed to be that the user will look at it and think, oh, this finance app wants to take photos with my webcam, I won't let it. I'm not completely convinced that that would always work with users, because you see, not so much for the Windows Store apps, but I've seen some crazy things with mobile. I mean, I've seen literally an app that wanted to be able to send SMS messages on my behalf and also post messages to my Facebook page, which I was just never going to allow it to do, but I think people are stupid enough to do it. So that's capabilities. The other important way that these apps can actually share information between them is a thing called a contract. So I don't know if any of you Windows 8 users have ever noticed, but when you swipe to the right and you see your Charms menu, the second one down is the actual sharing charm. What a really stupid name Charm is. It really is a stupid name. Anyway, that's what it's called. So if, for example, you've got an app that deals with photographs, then when you actually develop it, what you can actually specify is you can say, I want my app to be able to handle photographs. So you create that as a contract between, I suppose, between the app and the operating system. And then when someone attempts to open a photograph and they swipe to the side to share that, you will see that your app there in the list of contracts. And that sharing actually occurs via a brokered process. So that's another way that these apps can share information, and then have a brokered process. And you will actually see it, it's called runbroker.exe. You can actually see it in Task Manager when you run that. I'm going to have to apologise for the next slide in advance. I just couldn't resist getting a picture of a couple of surfaces in. The one on the right is actually Surface RT. And what I wanted to talk about here is the Windows Runtime, or WinRT. Microsoft caused a huge amount of confusion by calling their original Surface the Surface RT. And nobody understood what that was all about. And I actually got asked a question about it last year. The reason the original Surface RT was called the RT is because it has to, the version of the operating system has to write to the Windows Runtime API. And so basically, Windows RT is in fact not an operating system as such. Well, it is an operating system, but it's an operating system called after a runtime. And it's a platform where you actually have to develop to the Windows Runtime API. And the API itself is a somewhat cut down version of Win32. It's not designed to replace Win32. It's designed to actually complement it. And one of the most important things about it, here it is, by the way, that's the way the traditional, on the right, the way that a traditional app would work. On the left-hand side, the way that one of these, and I see that the word Metro has actually crept into that one, so it actually must have been a very, very, very early slide. As far as development environments are concerned, I think this is of some interest. Just pull all these up very quickly. These are the three ways that you can develop a Windows Store app. First of all, the most traditional way you can develop in .NET, and basically most of them are in C#, or if you're a very traditionalist, you can develop in C++. But the way that I think that Microsoft are trying to push it is that quite a lot of these apps are actually written in JavaScript, which is actually quite a scary concept. I always think of there's a famous book called JavaScript, The Good Bits, and I always think that the book would be like that, and JavaScript, The Bad Bits would be like that. The different percentages that these things run as. So not surprisingly, perhaps 59% of the apps so far are written in .NET, a mere 5% in C++, and 36% of them in JavaScript. I think that a lot of people, these things are being developed in C just because a lot of the people that come from that traditional Microsoft background know C already. And I've seen some apps out there that obviously are just absolutely crying out to be written in JavaScript. They're basically just like a series of pages or informational pages. And instead they're written in C#, and I think to myself, why? The way that sort of you would develop with this, unless you're an absolute lunatic, unless you really seriously want to challenge, the best way to develop with these things is in Visual Studio. Several reasons for that. Firstly, when you actually do develop one in Visual Studio, it puts certain headers by default into the compiler and the linker, and it introduces certain security features which Microsoft will actually check for. So if you've not actually compiled it with Visual Studio, you go and compile it with something else, you've got to check that you've put these features into it, otherwise it just won't pass certification. Visual Studio Express for designing Windows 8 apps is actually completely free, so you don't need the full professional version, which costs anything from £500 up to thousands and thousands of pounds. And the tool that you can see in the middle actually comes with Visual Studio and is actually also free, and it's quite a good kind of like WYSIWYG HTML editor thing on steroids, and that's called Blend. The store requirements and certification. So finally, when you actually got this thing created, you can actually get it in Visual Studio and you package it up and prepare it for the store. And once it actually gets into the store, you can have the privilege of paying Microsoft 30% of your earnings for it if you choose to actually charge something for it. So there's lots of different requirements that will actually have. Most of them from a security perspective are fairly irrelevant. I mean, they've got to do with development practices. They've also got to do with things like, for example, you can't package up your splatter game and then say that it's suitable for 3-year-olds. You can't sort of put pictures of nudie ladies unless they're in the context of the game, and a load of stuff like that. And then you give it a whack. The whack is the Windows Application Certification Kit. So you can actually run this within Visual Studio, and it will basically tell you whether your app is in a condition to pass. Just because it passes your local check doesn't necessarily mean that it will pass. I'm not sure what percentage they actually reject at that point, but I don't think it's particularly high, and they're supposed to tell you why you don't pass it if you don't. So, as security people, I suppose everyone will actually be interested to know, what do Microsoft actually do to check these things? What security tests do they actually carry out? Well, basically this. First of all, they run this bin scope binary analyzer thing. I mentioned before that you probably want to compile these things with Visual Studio. That's because you'll notice there, for example, one of those things is ASLR. Well, Visual Studio will automatically compile that into your code unless you deliberately turn it off. So these things that it's looking for here are basically security options to do with the compiler. And then the other thing that they run is this attack surface analyzer, which seems to be that it will check the integrity of the actual system itself after the app has been installed. So it will make sure, for example, that you've not gone and corrupted the registry. It makes sure that you've not done certain things that are bad for performance. Bearing in mind that another important feature of these apps is that they're not just designed for the x86 architecture, they're also designed to run on low-powered ARM processors and battery-powered devices. So a lot of the things that they're actually checking for, they're checking to make sure that your app is not going to be a battery hog that's going to give Windows a bad name. And last but not least, very, very, very importantly for Windows, they're checking for malware. So this is all well and good. I mean, these are great. It's great that somebody's doing this, but great, fantastic. But I'm sure anybody who's being tested can see where I'm going here. When I was researching this, and incidentally, it's quite hard to do because although Windows 8 has just passed its major milestone last week, it actually got more than 10% of the Windows install base. There's not much information on the internet about this, but one thing that I found was a presentation that 2 guys from Trend had done at Black Hats USA in 2012. And basically, wow, they've done a load of stuff that I really wouldn't understand. They've really put the thing through its paces at very much a binary level. So they talked about trying to exploit, talking about trying to jump out of the sandbox, and trying to find kernel weaknesses, trying to exploit COM, trying to exploit APLC, which I hadn't even heard of before that. That was one of the things they tried to do. So they looked at all the things that would protect the OS. They looked at a load of things that would protect against malware. But to me, as a web app tester, what they didn't do was something really very, very important. I mean, they actually came to look at it right at the end. They spent the last 5 minutes of their presentation talking about this. Because what Microsoft have not even attempted to do with these apps, and what I'm not sure that they could do, even if they did attempt to do it, is they have not even attempted to protect against the consequences of the fact that I'm user A, who has actually sort of installed the application, and I'm going to then try to leverage that application that I have on my local PC, either to attack the application itself, to attack the servers that it's based on, or to jump via those servers and attack another user of the application as though it were a website, and to do that via a server back end. So bear that in mind, because I'll come back to this in my conclusion. But before I do that, I'll just talk about the part that I thought people might want to hear about, which is how you actually go about testing these things. I think this is going to be quite important to know, because I really honestly do believe that these things will explode, and we will all start, we professional testers will actually start having to test these in the near future. So first of all, I'll talk about where they're located, some lessons that we can gain from mobile, what approach we should use for testing, what software we need, the JavaScript HTML apps, how to decompile the ones that are written in C, what the apps do with local data, and lastly, web services. I'm going to have to sort of kind of apologise for the slight slant towards JavaScript and HTML in this. That's because I do web tests and I don't know a lot about C#, but I try to cover that a little bit as well. So first of all, if you're asked to test one of these, you know, where the hell are they? Where do they don't, when you install one, it doesn't ask you, it doesn't say where do you want to install this to. They're in C program files, Windows apps. If you go looking on the internet, you'll find stuff about they're installed in applications. They're not, they were in the beta, but they moved it. And that's hidden. So first of all, what you need to do is put hidden files and folders on. You're probably a tester, so you've probably got that turned on anyway. Then you have to go to the security tab and actually take ownership of it, because by default, you know, nobody's got any access to it. And then, last but not least, you have to take control when prompted. So you have to go into the security tab, change the ownership of the files to yourself, go right out of Explorer altogether, go back in, take control, and then it will go through. You see it applying the access control to all the files in the directory, which are a lot. From all these things, you've got to be logged in as an administrator. And when you've done those things, you'll actually see the list of apps. So there's a list of some of the ones that I've got installed on my PC. They all come in their own individual directory, and they've all got an individual name, and then at the end, a kind of GUID thing that was put on by Microsoft. You'll notice most of them at the end say neutral. Neutral, as far as I can see, indicates the fact that they run on both types of processor, so x86 and ARM. And when you actually delve down deeper into the directory structure, it's quite, in fact, trivially easy to tell the difference between the JavaScript ones and the C ones, because the big giveaway is that the JavaScript ones have got directories called CSS and JSS, and they've got a default.html file normally, whereas the ones that are written in C# and C++ have got an exe file and one or more DLLs. We're almost talking about mobile apps here. We're talking about something that is very different and alien to the normal way a Windows binary works, where the actual vendor of the operating system is attempted to take control. And that kind of reminded me of where we are with mobile. So I looked at the OWASP Mobile Top 10, and you can see that most of those actually sort of have got relevance to web apps as well. And I kind of think of a Windows Store app as a combination between a mobile app, a traditional Windows binary, and a kind of website. So you turn that on its head. This is Microsoft's guidelines for developers of these. These are the things that developers should do. And again, you can see there's a lot of commonality with web apps. For example, don't trust in remote data, validate content, use HTTPS. There's a couple of ones there that are pretty unique to the Windows Store app, which is don't let the web access WinRT. In other words, you don't want to give the app more control over the operating system itself. You have to, particularly if it's untrusted content coming from the internet. Use the file picker instead of library capabilities. Again, that means that there's a tool called the file picker where the user gets to actually decide what files you're giving the app access to, rather than just blanket giving it access to your whole picture library. So those two things together give us an idea of where we're going with it. And testing approaches, the most obvious approach I think with these will be to think, right, okay, what will we do? We'll just jump out of the sandbox. Well, I mentioned those guys' presentations at Black Hat. If you attack the sandbox, what you are actually effectively doing is you are looking for a vulnerability either in the Windows kernel or COM or the Windows RT runtime. People who are security researchers may well find these things. What we get given is 4 days to do a web app, or 5 days to do a web app. We're not going to find a vulnerability in the Windows kernel. And frankly, if we did, I don't think our customers would thank us for it. They would say, right, okay, you found that. With a bit like Microsoft will give you £100,000 for it, but it won't have helped the security of our app one little tiny bit. So that wouldn't be how I would approach it at all. What I would say is approach these applications as though they were web applications. Look at local data. That's something that we get from mobile. If the code is compiled code, well, decompile it, and then, in as much as you are capable of doing so, carry out code review. And lastly, but not leastly, by their very nature, these applications have to make a really heavy use of web services. And web services, as every tester will know, is a very, very rich and fruitful area for exploration and test, because it's something that devs tend to think that you don't have to secure. So as far as your software setup is concerned, it probably goes without saying you really need to have Windows 8 for these. They don't work in Windows 7 like a bit at all. They won't ever. You can't fiddle around with them and make them work. I've not tried, I was going to if I got time to see whether I could coax them into running in the server environment. I don't know whether you would be able to or not. There's a desktop experience pack that you can install on that. I don't know whether that works. The other thing that you need to be able to do in order to be able to run these, you have to have a Microsoft account, which doesn't necessarily have to be like Outlook or Live or anything. It just has to be an account that you've associated with Microsoft in order to be able to download them from the store. When you run these things, you cannot be logged in as a local admin account. If you logged in as a local admin account, it will just bob you out and say that you can't do it. And if you look on the internet, you'll find that there's various hacks for making registry changes so that you can run them as local administrator. As far as I know, none of them work since Windows 8.1. And so they've done a lot of tightening up of little loose parts. So a lot of the things you find out on the internet about these things just simply aren't true anymore. Then the next thing you need, obviously, is a web proxy. Normally, like most testers, I use Burp. For these, I would strongly recommend the use of Fiddler. It just seems to work like about 1,000% better. I don't know whether it's just that these apps actually, the JavaScript ones, they actually run as a kind of headless version of Internet Explorer. So I think that because Fiddler is like kind of closer to that code, it seems to work better. It also has some Windows 8 specific features, which I'll come back to in a moment. The other thing that you need is a decompiler. I personally use .NET Reflector because I find it very good, but there is a small cost associated with it. I think it's £75 a license. So you can use .peak instead, which is open source freeware. It keeps crashing my machine all the time, but I don't know whether that's just a common thing with it or whether it's just my machine that it does it on. Also, as I said earlier, Visual Studio really, really useful if you're going to test this type of app. Before you start, this is the most important thing, because I wasted hours the first time I tested one of these. By default, they cannot talk to the local loopback address, and therefore they don't work with a web proxy. So you fire up your web proxy, and the first thing that you notice is that you just don't get any traffic through it. To actually be able to see the traffic from them in a web proxy, you have to be able to, activate the loopback exemption, which is something that's been put there for developers to do. So in order to be able to do that, you actually have to have a developer license, which is what you get when the first time you go into Visual Studio and you go to create a Windows Store app. It'll ask you whether you want a development environment license, and basically if you don't want one, you can just go away because you're not going to be able to develop one without it. If you do want one, then they just hand you out one. It doesn't cost you money, and you just get it for 3 months. And your app is registered as your machine is registered as a developer machine, and that's you go down a list somewhere at Microsoft, and your name is recorded for future reference. But once you actually do that, if you then click exempt all, then all your apps, all your Windows apps will then start running through the proxy. You then bypass one of the most important security features with it, because obviously if they can talk to the loopback address, it kind of gets around the fact that one app can't talk to another app without going through the broken process. So do remember to turn it back on. And another thing to bear in mind is that if you do have the Windows firewall turned on, it interferes with them as well, like something else. So turn it off. You've probably tested. You've probably got it turned off anyway. So the JavaScript HTML apps, as I say, I thought that Microsoft were really pushing these when they first started coming out, but they're still very much in a minority. These really honestly are web applications. You really can test them as though they were a web application. They have a concept of local context versus web context. If a page is included with the app itself as part of the package, it's considered to be local context. In the local context, it can access WinRT, but any remote access to it, any script, will have dynamic content filtered out of them. So the web context is any page that's actually included as part of the app that isn't actually in the package itself. And in that context, scripts will run, but they are treated with the same limitation as far as domain access and cross-access and so on, that they would be treated by an ordinary web app. So it's these things, as I said a moment ago, run as a sort of headless version of IE. If you've ever wondered what that WWA host.exe was that you see lots of running in Task Manager, that's what it is. I call it the WA host. I'm not sure whether that's an official sort of thing at all, but it is IE10. Interestingly, although when you went from Windows 8 to Windows 8.1, IE was upgraded from 10 to 11. This doesn't actually seem to be upgraded. It's still got exactly the same headers as it had when before, so it still seems to be a headless version of IE10 rather than IE11. And these apps, they suffer from what I would describe as the typical problems of apps that have got a good framework. So in other words, you're not very likely to find cross-site scripting on them because the framework protects you against a lot of this. It uses the anti-XSS version 3 library. So if you can break that, then you found a genuine bug in it, but you're not going to find anything that's got completely untrusted input in there unless the developer has actually deliberately gone out of his way to include it. So it's, you can get it, but you can always get it, but it's pretty unlikely. And they're really no more likely or less likely to have other flaws than any other web app. That you can see the WAR host, as I call it. Notice that, that an important feature of these apps, as I said before, is that they save battery power. So you can see there in Task Manager that they're all suspended. That's because I'm actually in the desktop. So within 10 seconds of me going into the desktop, it will suspend every single one of those in order to save its little battery. One of the other things you can do is decompilation and code review. I don't know, there's something about an exe file that makes developers feel safe. They feel, oh, we've got an exe file, nobody can look inside it, we've got this DLL, no one can go read the code. When these things first came out, there was a load of bleating that you could actually see on the internet with people going, oh, there's a JS directory there, it's got code inside it, you could read the code, and oh dear me, as though you couldn't do that on websites anyway. I wondered to myself whether some of the stuff that's actually been written in C has been written in C because they think that makes them safe. Well, it's not, because you can pretty trivially decompile them, and you can run them through an obfuscator as the dev before you do it, but it still doesn't really defeat anybody who's really determined. It just makes it more difficult. As with all these things, a lot of how much you can do depends on your ability to read the language. But even if you can't read the language, if you can't read C#, you can still gain enough about it to be able to go through it and look for certain things. So for example, you could be looking for credentials, you could be looking for API keys. And one particular app that I looked at, it had a developer mode, which was turned to false, and there was actually a little comment underneath, and it said, do not turn this developer mode to true because it will give you a whole lot of access you're not supposed to have. Which is obviously a big temptation to any tester. And SSL, that's Microsoft saying that you should always include that particular tag in your HTML for your page. So you can look for that, and if it's not there, then that means that SSL is not necessarily turned on. Like most things, you've got eval and exec script, which are not very desirable bad coding practice, but they also have some other functions that are specific to this. So you notice that they actually put the word unsafe in it, and basically when you use that, that means that you've effectively turned off input validation on it. So one of the things you can do if you're actually searching through code is look for the word unsafe and see what you actually come up with, and there you can see an example of a kind of bad coding practice which uses eval and then incorporates it back into the page at the end. And then you get XML HTTP request, which is also quite an important one to look for. That's not bad coding practice as such, but what it actually does is that's a request for authenticated access, and when it makes that request, it will pass any session cookies that have been generated along with it. So looking out for that in conjunction with no SSL is actually very bad practice, and it's something you should be looking for. And then of course you get untrusted dynamic content, where that one is actually sort of writing back to the DOM straight with the response text. So these are just web app flaws. Local data, as well as the package directory, there's one other place that apps are allowed to write to, and they write to that directory, C users, and then app data packages, and then the app name, and that's where they store the state of the app. So one of the important things about store apps is that you're supposed to be able to flip between one and the other, so that they have to be in a position where they can be suspended easily, and then they can come out of suspension equally easily. So where they store like the suspension data is in the local state directory underneath that app name. And remote state is where they store it between machines, because you can, once you've downloaded an app from the Windows Store, you're entitled to use it on up to 5 machines. So the idea is that I, for example, could close this laptop, I could go over there, I could pick up my Surface and open it, and if I was in an app, I'd be in exactly the same page as both. I find that remote state quite scary because it stores the up to 100K of information in the remote state directory, but Microsoft don't ever tell you where that's stored. I mean, where does it go? I mean, it obviously goes on their servers, it goes out on the internet, but where? Is it in the United States? Where is it? Do the NSA have it? Probably. My last point, web services. Lots of these apps use them, basically because they've not got any choice, because they are, unlike ordinary Windows apps, they don't get the option of using a lot of native networking. So basically they use HTTP or nothing. They can't talk to a SQL database raw. They can't open ordinary TCP connections. They have to use the port 80 or port 443 and the HTTP protocol to do it. So I've generally found that the attitude of developers to web services is kind of like la 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 la. Because they think that out of sight, out of mind. They think that, you know, because they're not there in the GUI, you're not seeing the operation of them, that nobody will interfere with them. But of course, with a web proxy, you can go and interfere with them to your heart's content. That's a SQL injection error that I found. I took the customer's name right out of, but you can see that that was an unauthenticated error-based SQL injection in the web service. You can see that when I've divided it by app version, it's come over. In that particular case, I was able to enumerate very, very slowly the entire contents of the customer's data. So very quickly, before I finish, a little interlude. I started looking at store apps last year, and I actually started writing a presentation for a different conference that I never ended up doing. And at that point, there was a lot of things that you could do with them. I'm sad to say, a lot of the things you can't do them anymore because Microsoft have gone and tightened up on them. So what you used to be able to do is, if you got an app that you didn't like the look of, and I really didn't like the look of this one, why does everyone think that hackers are like ninjas, and you know? So I really didn't like that, so I just thought it might be nice to have some cats on it. So I just changed that, and you used to be able to sort of quite trivially change it, but Microsoft have now taken the belt and braces approach to this. So I mentioned integrity levels before. They've actually now enforced the integrity levels, so it makes it really, really difficult to actually physically modify the files that are in that directory, because Windows constantly sees this integrity level and it won't let you play with it. So I decided to do a little bit of a hacker's trick and take Linux to the rescue. So what I actually did was created a Windows 8 VM and downloaded some apps, and then shut that VM down, brought up a Linux VM and attached the disk from the Windows machine to the Linux machine. At that point, Linux had the file system mounted, and Linux doesn't know anything at all about Windows integrity levels. They won't. And it let me go in there and modify it, and then thinking I was being very clever, restarted Windows, and sure enough, I can now see the files there in the directory. I can see the ones that I changed. I can see the fact that I put little cat pictures in it. But as soon as I tried to start the application, forget it. Because what they've done is they've included a checksum in there and a certificate, and if the code signing certificate, and if that is modified, it just won't run the app. It just says, you know, your app has become corrupted. It doesn't actually say you've been hacking around, sort of, you know, your name's been written down in a book somewhere. But what it does actually do is just direct you back. So you can't do that. You used to be able to do it. I talked about integrity level. That's Process Explorer from sysinternals, and there you can see all the different things running as those WAR hosts that I talked about, and they're running with that app container. However, you'd think that from what I just said that there wasn't much point in me actually saying, oh look, I saw an app that had dev mode on it and you could turn it off and on. Well, there's one thing that I'm not sure whether I'm the only person that thought about it, but I thought it was quite a cool trick. You can actually make a modifiable copy of a store app, at least of a JavaScript, where I'm not trying it with C#, I think it might be possible. But what you actually do is you just go into the default.html or whatever that file is actually called on a particular app, and you look to see what template it's based on. And by default with Visual Studio there's only 4. And so you look to see what it's based on, and then you actually go into Visual Studio and create a project yourself. You can call it anything that you like, and you just save it with the same template, shut it down, shut Visual Studio down, and then you delete the JavaScript, the style directory, and the default HTML file from the one that you just created. And if there's a pages directory, you delete that as well. And then you copy the stuff from the other app and into that, and then you just build it. Oh, sorry, then you have to add any resources like images to it, just in the normal way in VS. And then you build it. And at the end of it, you get a working copy of the application, but it's actually just running on your machine, and you can play around with it and change it to your heart's content. So if, for example, the dev has got something like they left dev mode enabled, and you can just change it from false to true, and you can then do that. And generally, I've found from playing around with them is that doing this in no way, shape, or form invalidates them at the server end. So you can still sort of talk to the web service to your heart's content, so you can play around with it that way. Conclusions. The risk of it, for anyone who listened to my husband Rory's presentation before, I'm going to ask a question now where I might be accused of being a cultist and might have my soul devoured by the great old ones for asking it, but are these apps actually secure? Rory says that's a bad question to ask. Well, in a way, yes. Yes, these apps are, very secure in a way. They're certainly a lot more secure than going out on the internet and just finding sort of coolgame.exe and downloading it and joining the bot army in Taiwan or whatever that was. And Microsoft have gone to a lot of trouble within their remit to make sure that the apps that are in their store are free from viruses. They aren't going to cause your PC to crash. They're not going to eat up your battery power. They're not going to consist entirely of advertisements. That they are nice apps. So yes, in that respect, they're pretty secure. But no, Grumpy Cat says no, they're not secure at all because they can't be, because Microsoft cannot be the world's policeman on this any more than Apple or Google could be. They can't be expected to go out there and check every web service. I mean, say you've got a web service and you've got 14 different apps on different platforms that are all pointing to it. That the person that runs that server isn't going to be very happy if they discover that, Microsoft's test is just they found SQL injection and they've taken it down. So they do not, even within their own context, attempt to protect against a lot of the very real dangers with web applications. So for example, these store apps will not do anything. If you are user A and you have put your personal credit card details into this application, and then user B, who's also got the application, downloads it, looks at the code, and says, oh look, okay, I can see the web service, I can see it's got SQL injection, I've downloaded that database, I've cracked it, now I've got all your credit card details. There's nothing that these store apps can actually do to protect you against that. So I'm afraid in conclusion I have to give a kind of resounding maybe. It really depends on your definition of secure, as so many other things. Questions? Questions? Good. To anyone who wants to know how to get that effect, it's very, very, very difficult to clarify.
You just answered my question. So you think you can clone apps for testing purposes, so you can dump
Yes.
it into your studio. Is there the possibility that you can sideload these apps and people could...
Yes, you can sideload them, but only onto another developer's machine. So what you can do is you can package that app, because it actually creates an app package for it. So you can send that to another developer, and or copy it to another developer, and they can then run it on your machine. Now, I don't think that it's actually enforced how many people you can send it to, but the guidelines say you're not supposed to send it to more than 10 people. And it actually does say that if they catch you in fraudulent activity, they'll take your license away. So I would imagine if what you do is you go and design an app and then you say to 100 of your friends, oh, go and have a license for this, and so you just go into this and you do this, and then you're all sideloading it. I would imagine that if they found out about it, they'd be very annoyed.
Or does that mean we're in the position, a la Android, where people can download versions of paid apps that are actually just exfiltrating their data?
I wouldn't be surprised. I've never actually personally tried to do that, but yes, with a developer license, you could probably do that. On an open platform or a relatively open platform like the PC or like Android, there really isn't an awful lot that you can do to stop that kind of behaviour.
Thank you very much.
So you've been talking about the Windows and Windows RT. How much of what you've been saying today is also applies to the Windows Phone apps?
Well, they say that about 95% of the runtime is actually common between the two. But of course, Windows Phone is an even more controlled platform than, I've done a little bit of trying to hack into Windows Phone, and it's not tremendously easy. So you can't do a lot of those tricks, or at least I wouldn't know how to do a lot of those tricks where you can't actually get access to the file system. I suppose the difference between this is that I'm able to, because it's a PC, I can actually take ownership of it. You wouldn't be able to do the same thing with Windows Phone. But I think in general, the comments about web services, for example, would apply just as much to Windows Phone as they apply to this type of app. And indeed, if I may make one comment, I will be very surprised if you don't see effectively what is Windows RT for tablets become the same thing as Windows Phone later on this year.